Last period I am discussed the nitration rule. Then today I am discussing fragmentation patterns of selected classes of organic compounds. Then first we see what is meant by nominal mass. Nominal mass is nothing but it is a mass calculated from the formula by summing constituent atoms in it. Then general rule for fragmentation pattern. First rule is cleavage occurs at alkyl substituted carbon so as to form a stable carbocation. This is the first rule of fragmentation. Then second rule, carbon-carbon double bond and arenes tend to resist fragmentation. Then third rule, allylic carbons are stable and resist fragmentation. Then fourth rule is neutral fragments such as CO, C2H2, water molecule, ammonia, hydrogen sulfide are frequently lost. And fifth rule for fragmentation pattern, even electron rule. Even electron rule means it is a species or cations fragments to another cation and neutral molecule but not into two odd electron species. This is the even electron rule. Then sixth is the nitrogen rule. Last period we studied this nitrogen rule. That is compound lacking means no nitrogen atom. Compound, organic compound lacking or containing even number of nitrogen generates molecular ion having even number of mass to charge ratio, or compounds containing odd number of nitrogen generates molecular ion having odd number of mass to charge value. Then first we study fragmentation pattern in case of alkanes. Then for example, fragmentation of normal hexane. Normal hexane, here different fragments occur in case of normal hexane when applied into mass spectroscopy. First we study the fragments. First fragment is the methyl, that is CS3. Here mass to charge ratio of methyl is the 15. 1 carbon atom, 12 and 3 hydrogen atom. Summing this atomic mass, that is a 15. Then ethyl C2H5, mass to charge ratio is the 29. Then propyl C3H7 having M2Z value is the 43. Then again butyl C4H9 having value 57. Then pentyl C5H11 having M upon mass to charge ratio value is the C5H11. And last is the hexene C6H14, mass to charge ratio value is the 85. Here you see that propyl and butyl, these two fragments occur in most abundant fragment in mass spectroscopy. You remember that here methyl, ethyl, propyl, butyl, pentyl and hexyl, these fragmentation only differ in CH2 group. That is, difference between methyl and ethyl group is the only CH2, or ethyl or propyl is the CH2 group. Means this fragmentation occur by differing in CH2 group. And this M to charge ratio is the summing of constituent atoms. In case of the CH3, 1 carbon atom, 3 hydrogen atom. In case of the ethyl C2H5, 2 carbon atom, 24 and 5 hydrogen. Therefore mass to charge ratio is the 29. Similar in case of the propyl, butyl, pentyl and hexyl. Then here we see the structure of normal hexane, or I am showing you mass spectrum of normal hexane. Here fragmentation CS3 mass to charge ratio is 15. Here ethyl 29, propyl 43, butyl 57, pentyl 71 and hexyl means normal hexane release one of the electron by bombarding high energy electron hole beam by electron gun. Then it form the hexyl, that is 86 is the molecular ion or parent ion. And here methyl, ethyl, propyl, butyl, these are the fragmentations occur in the mass spectroscopy. Here we see the mass spectrum of normal hexane, that is here propyl and butyl, that is the propyl having mass to charge ratio 43 and butyl is the 57. Then you see here line 43 and 57 as a baseline, and 71, that is a pentyl, this cation occur in very least proportion, and propyl and butyl occur in the more or most abundant fragment in the mass spectroscopy. This is the fragmentation pattern of normal hexane. Here straight chain alkanes always gives a molecular ion. Molecular ion means in case of the hexane, hexyl is the having mass to charge ratio 86 is the molecular ion. Straight chain alkanes always gives a molecular ion peak, but its peak intensity decreases as chain length increases. The base peak is usually at M to Z ratio is the 57, correspond to the C4H9 carbocation. Then fragmentation at carbon-carbon bond produces a mixture of alkyl radicals R dot and the alkyl carbocation, that is R plus. The smaller fragment retain positive charge. A cluster of peak separated by M to Z value of 14 mass unit is often seen. They represent alkyl cation homologous differing in the CH2 group. That is hexyl mass to charge ratio 86, pentyl 71, butyl 57, propyl 43, ethyl 29 and methyl is the 15. These cations. Normally the highest peak in the cluster is at M upon Z is equal to CnH2n plus 1 or 14 in bracket n plus 1. The by corresponding alkyl carbocation formed by losing 2 hydrogen atom, so their mass to charge ratio is the 55, 41 and the 27. This is the fragmentation of alkane. Similarly, another group also shows the fragmentation in the mass spectrum, that is alcohol, amide, ester, ketone. This group also show fragmentation in a mass spectroscopy. But first we study in case of the straight chain alkane. Example of straight chain alkane is the normal hexane, and this normal hexane showing the fragmentation. Hexane means 6 carbon atom, therefore there are the 6 fragment. One fragment is the methyl, another fragment is the ethyl, third is the propyl, fourth is the butyl, fifth is the pentyl, and sixth fragment is the hexyl. Means this normal hexane molecule break one of the CH bond by bombarding high energy electron hole, that is 70 electron hole by electron gun. Then formation of the hexyl is the parent molecular ion having mass to charge ratio is the 85. Then another CH bond breaking, then formation of methyl cation, ethyl cation, propyl cation, butyl cation and pentyl cation, etc. But in case of propyl and butyl cations, these cations occur in the most abundant in nature. Therefore mass spectrum of these 43 and the 57 show the more line intense peak, that these peaks are called as the base peak. Here pentyl having mass to charge ratio is the 71, and you see in mass spectrum very short line 71 means least abundant fragment occur in case of the mass spectroscopy, and more abundant fragment is propyl and the butyl. Therefore this is the mass spectrum of normal hexane, and these are the fragmentation of normal hexane. Means one fragment is the methyl, another fragment is the ethyl, third is the propyl, fourth is the butyl, fifth is the pentyl, and last one is the hexyl. and their molecular M to Z ratio is the first fragment methyl is the 50, next is the 29, third is the 43, fourth is the 57, fifth is the 71, and last one is the 86. This is the fragmentation pattern of alkane, and we see here fragmentation pattern of alkane is the normal hexane. The next period we study again fragmentation in case of the ketone, aldehydes, amides, alcohols, etc. Thank you for listening.